What if I told you a mushroom could solve a maze faster than your laptop? And no, this isn't a stoner's dream or a sci-fi movie. It's science, real, peer-reviewed, lab-coded science. Welcome to the bizarre and brilliant world of biocomputers, where mushrooms, neurons, and slime molds might just be the next generation of processors. Imagine walking through a forest, stepping on a patch of moss, and unknowingly disturbing a vast underground internet. That's not poetic. There's literally a network beneath your feet. Mycelium. The root-like web of fungi that connects trees, transfers nutrients, and now is being studied as a potential living computer. You see, mycelium doesn't just passively sit underground. It pulses. It reacts. It communicates through electrical signals. And here's the part that melted scientists' brains. Those signals aren't random. They appear to carry information. Input, processing, output, the basic recipe for computation. In one mind-bending experiment, researchers gave mycelium a maze, like a little fungal escape room. And guess what? It solved it. The mycelium grew through the labyrinth, finding the shortest path to food. It didn't just stumble around, it optimized. When the same maze was presented again, it completed it faster. That means it remembered. It learned. Now think about that. A fungus with memory. Scientists are now attaching electrodes to mycelium and reading its electrical impulses like Morse code from nature. These tiny voltage spikes can be interpreted as bits of information, just like how your computer reads binary code. But instead of ones and zeros in silicon, we're talking wet, organic, squishy logic gates. But fungi aren't the only living circuits. In a separate experiment, researchers grew a cluster of human brain cells, actual neurons, in a dish and taught them to play Pong. You know, that click-salated paddle game from the 70s. The neurons weren't just passively reacting, they were improving. They got better at the game over time, adjusting to feedback. So yes, we now live in a world where human brain matter in a petri dish has better hand-eye coordination than your Uncle Steve. Why go through all this trouble? Because silicon, the lifeblood of modern computers, is hitting its limits. We're reaching the physical boundaries of how small and fast we can make transistors. Biocomputers offer something wild and new. Systems that are energy efficient, self-repairing, and able to adapt on their own. Think of a computer that heals itself when it breaks, that grows organically to expand its memory, that doesn't just follow instructions but learns how to solve problems it's never seen before. Some scientists even dream of mushroom-based data centers. Imagine a future where your city's AI runs on a forest of glowing fungi, communicating in electrical pulses beneath the ground. Sounds like Avatar meets the Matrix, right? But the real-world applications are already taking shape. Environmental sensors made of fungi could grow into polluted soil and alert us to toxins. Biocomputers inside the body could diagnose diseases from the inside and release medicine only when needed. Nature as doctor, nature as computer. Of course there are challenges. Fungi aren't exactly plug and play. They're slow, they're unpredictable. They hate dry air and strong Wi-Fi. But every great technology started clunky. Remember the size of the first computers? They filled rooms and crashed constantly. Now they fit in your pocket and crash slightly less. The point is, we might be looking at the first awkward steps of a whole new form of intelligence. Not artificial intelligence. Organic intelligence. And maybe, just maybe, mushrooms aren't just food or fungi. Maybe they're thinking. So next time you see a mushroom sprouting after the rain, don't kick it. Respect it. It might be solving a math problem or planning to beat you at Pong. If mushrooms can think, can they dream? Let that question haunt your sleep.